In this lesson, we're going to look at trigonometric graphs, but we're trying to actually work out the equations from the graph. So looking at a graph and trying to work out what it is it 3 sine 2x plus 1 and so on. So here's a brief revision of all the graphs you've learnt. The sine wave, that's periods 360, it finishes at 360, one full cycle. The amplitude's the height from the middle line, so it's just 1. Cosine wave, very similar, periods 360, amplitude's 1, it starts up high and down low and so on. The tan graph, its period's only 180 before it starts to repeat. You can see it going up here and up to there, and then it starts to repeat. The amplitude of this graph is not measurable. So again, a revision here of what the equations would look like for various graphs. For sine and cos, they look like this. So the number at the front is the amplitude. The amplitude of a sine wave is normally 1, but you could have a 3 at the front, which means it would go up to 3 and down to -3. Or you could have a negative number, which means it would flip it upside down, if you like. The number in the middle here is how many waves there are in 360 degrees. And you can get the period of a wave by doing 360 divided by whatever that number is. And the number at the end is the vertical shift up and down, how far up or how far down. If it's a downward movement, it would be a takeaway at the end. The tan graph is very slightly different. The amplitude is not measurable in a tan graph. We'll talk about this value at the front in a second. The B part, because the period is 180 degrees, the B part is how many waves there are, or graphs, sorry, there are in 180 degrees. That's slightly different. And to get the period, you do 180 divided by that. The vertical shift in up and down is just the same. This number at the front, because the amplitude is not measurable, then often or sometimes in a tan graph you see a wee 1 here to show that this value here is round about 1. Now if there's a 5 at the front, you can change that to a 5, or a 6 at the front, you can change to a 6, or say there's an 8 at the front, you can change that to 8. But ultimately we don't really look at too much of that in detail. Right, let's get started. So trying to recognise graphs. So I'll go through some questions here, and then I'll do some from the book, and you can finish the exercise yourself. So we're trying to work out the equation of the dark line, not the dotted line, but the completed line. Now there's quite a lot to think about here. The first thing is, what is it? What type of graph? You've got to think, is it a sine wave or a cosine wave? We're not really going to look at the tan graphs, we're just trying to recognise sine and cosine wave. Now hopefully you recognise, is that a sine wave? Now looking at the dotted line first, that's what I always do. Look at the dotted line first. It's a sine wave and it goes up to 5 and down to -5. So that'd be 5 sine x. That's my starting point. The next thing to get this, I think it's been shifted. So I'll look at how far it's been shifted. That's up 5, that's up 5, so +5, and that's you finished. Now you get quite a lot of marks for this. Look, that's 3 marks, 1 for the 5, 1 for the sine x, and 1 for the 5. So it's good to be able to do this, and it does crop up in higher maths as well. Okay, next one. Let's look at the dotted line first. Now hopefully you recognise that as a cosine wave. So it goes to 3 and -3, so that is 3 cos x. And then if you look at what's been shifted, this one's going down by 3, going down by 3, so that looks like a takeaway 3, just checking that out in every point just to make sure it goes down by 3. Now it's going to get slightly harder in the next set of questions. These are ones straight out of the book. You're welcome to do them all here, or you could do some of them here and then go to the book, or watch them here and then try them again in the book, whatever way you want to try it. But they don't have dotted lines on them, so I've drawn some dotted lines to start here. I might not do everyone because this is right out of the exercise. I might do the first 4 and then let you try yourself. However, what you can do is you can imagine that being there, okay, to try and think about where the dotted line used to be. But some people find that difficult. So my advice is, the first thing I would probably do here is I would work out the amplitude and think about what kind of graph it is. Now to me, that's a sine wave. Okay, so it's a sine wave. Now the amplitude is the difference between the top and the bottom, halved. So the difference between the top and the bottom is 8, and if you half that, you get 4. So it's 4 sine x. That's your starting point, 4 sine x. Now that's where my dotted line was, 4. That's a 4 sine x. Now I can think about if it was at 4, if it's going up as high as 4, what's been shifted up to get to 8? And if it starts at 0, what's been shifted up to get to 4? It's +4. Okay, again, look at the next one. If I try and imagine where the dotted line would be, that would be there, because it would be symmetrical either side. Again, but you don't need to do that. You could just work out the amplitude of this graph. Now, it's a cosine wave. Now, the amplitude, the difference of 6 and 0 halved, the amplitude is 3. So it would be 3 cos x. And this 3 cos x has been shifted up 3 places. So it's a plus 3 at the end. I'm going to try the next two without the dotted line. I'll just get rid of the dotted lines, because that's the way it is in the book. You don't have any dotted lines at all. I'll undo that. Get rid of that one as well. Okay, so how would I tackle this one here? So I know it's a sine wave just by looking at it. I'm going to get the amplitude first. So 9 and minus 3, that's a difference of 12. So I know it's going to be 6 sine x. So I know it's 6 sine x. So it should peak at 6. But this one peaks at 9. So it must be plus 3. There I have it. Okay, again, let's look at this one here. So I'm thinking it's a cosine wave. And the difference between 0 and minus 10 is 10. So the amplitude must be 5. So it's 5 cos x. So it was at 5 and minus 5. The lowest it went was minus 5, but it's now dropped to minus 10. Must be take away 5. Okay, I'll do one more of these and then you can do the last one yourself and some of the other ones. Or try them again. Watch me do them and then try them again in the book. Right, so this is a sine wave. I know it's a sine wave. And the highest is minus 2 and the lowest is minus 10. So that's a difference of 8. So if I half that, I'll get the amplitude, which is 4. So it's a 4 sine x. So it was at 4. The highest point was 4, and it's now the highest point is minus 2, so that's dropped 6. There you have it. Okay. Right, these ones are slightly more difficult, and I'll show you why. I'm only going to do the first two, and I'll let you try the others yourself. I'm going to get rid of the dotted line, if I can. Can I? Yeah, I'll get rid of that. And I'll see if I can get rid of this one as well. Yep, I can get rid of that. Okay, now, first thing to think about here is what type of graph it is. For me, that's a sine wave. And the amplitude this time is between 4 and 0, so that's a difference of 4 halved, it's 2. So it's 2 sine x, but there's something to look out for here in these harder ones. It finishes at 180. So I've got to be dead careful here. That's 2 sine 2x. That's 2 signifies there would be 2 waves in 360 degrees. So that's the addition in these harder ones, and you'll find them later on in the book, in the exercise anyway. Now, the last thing I need to think about is it was up at 2 and it's now up at 4, so it's been shoved up 2 places. Okay, last one I'm going to do here. So sine wave again. Let's get the amplitude. So the difference between 9 and minus 3 is 12. Half it, so it's 6. So it's a 6 sine wave. Now it finishes at 120 here, so that means there would be 3 that fit in 360 because 320s are 360. So that would be a 3x. Now it was at 6, it's now at 9, so up 3. Okay, have a shot of these yourself and see how you go. Now, I don't think at any point I ask you to sketch these, but you can. I'm just going to show you quickly. Maybe at one point it does what you can do here if you wanted to sketch that. My advice, if you're trying to sketch this here, would be to draw 3 sine 2x first. So that's the dotted red one. So sine wave up to 3 and down to minus 3, making sure it finishes at 180 because of the 2, and just shift all of your points up one position. But I don't think it's asking you to do that in the exercise really. So, but that's just a wee bit of extension if you wanted to try and draw those graphs.